All right, as we start chapter 11, you absolutely positively need your unit circle. So make sure you locate that. Now, chapter 11 is about trig equations and identities. And so, we are going to kind of start with the trig equations and learning about solving them for a few sections. And then we'll get into some trigonometric relationships, and we'll get into some of those identities, which are in your packet. And then we finish off with some more solving. Now, you might have been a little bit confused because it says 11.3. We're not going to do notes or have any problems from 11.1 and 2 because those are some things we've kind of already done already. So we're going to focus on 11.3, solving trig equations using algebra. Guys, can you get your stat box? Excuse me. So 1 and 2 are about A1 and A2. A1 is where you look at a graph and find your solutions. We talked about that with the review. There were a couple on the test where you had to find the number of solutions, and so we can do that. We know how to look at a graph and find solutions. Number 2 is like basically the same thing where you would graph it on like Desmos and look at the graph and find solutions. So that's why we're not doing notes or problems from this. And then number 3, what we'll be talking about today is how we can algebraically figure out what x is. So we'll do some algebra and use our unit circle. So when you solve trig equations, you do solve them the same way as you solve algebraic equations where you want to get like x by itself, right? But we'll end up, instead of getting x by itself, we'll get the trig function by itself. So it's like cosine x equals something, sine x equals something, tangent of x equals something. And then we look at our unit circle to find those solutions. Here's the trick. We know that these graphs go on and on forever. So really, there'd be an infinite number of solutions. Now we'll talk about like what that would look like if we had to do an infinite number of solutions. However, for the most part, we are going to focus on a finite number of solutions, which requires a domain. So if we say, well, we're only going to look at the function from 0 to 2 pi, we can find the solutions just in that part. Or maybe we extend our domain and it's 0 to 4 pi, and we'll talk more about that later, but we'd find all the solutions just in that part so that we don't have to find an infinite number of solutions. Now there is something, before we look at the infinite number of solutions, that we do need to remember as we solve these algebraically, and that is the period. And so I kind of just want to change that a little bit, but just remember that for sine and cosine, the period is 2 pi, and for tangent, the period is just pi. Now that is on the back of your unit circle packet, so if you forget, it's right there. But we will use this, so like if we have an extended domain, like let's say we actually have to find all the answers from 0 to 4 pi, then we will kind of add the domain to it, or not the domain, add the period to it to find our other solution. So I know that sounds weird now, but you'll see what that looks like a little bit later. We're going to briefly talk about what it would look like if we had to write all of the solutions, like all the way to infinity. Are there questions before we get there? So if we think about cosine of x equals -1, notice there's no domain. It just says cosine of x equals -1. We can look at our unit circle to find the answer. So look at your unit circle. What's the solution for cosine of x equals -1? Remember that all of your ordered pairs are cosine and sine, like x and y, cosine and sine. I know it also doesn't say, but I want you to give your answer in radians. x equal negative 1. That's fine. At pi. At x equals pi. However, if I did a full rotation all the way around, I'd have another answer, right? So what's a full rotation? Oh, that's the answer, but one full rotation is 2 pi, right? One full rotation. So what we'd have to do is we have to like add 2 pi every time, but if we wanted to write this answer, we'd have to look like x plus k2 pi, k is an integer. Because I'd have to add 2 pi to get 3 pi, then I'd have to add another 2 pi, and another 2 pi, and another 2 pi. And so I know that can be kind of crazy, but that's how we would represent an infinite number of solutions. Now we're not actually going to do a bunch of that, but we just wanted to explain to you again how we'd have to keep adding 2 pi and 2 pi and 2 pi till infinity to get all of my solutions, which is why it's unrealistic to do that. So coming up in the next examples, there's going to be a set domain saying, we don't want all of the answers, we just want the answers between a certain part of the graph for that set domain. So I would call this example 1. I know it doesn't say example, the examples are kind of not numbered in the notes. I would call this example 1, so, but we're just going to look at the finite number of solutions. It says cosine of x equals 1/2, and x is between 0 and negative 2. So this is our domain right here, this part. It tells us what part of the unit circle I'm looking at, and it tells us how many, we can kind of use it to figure out how many solutions. And I would say this is the easiest domain you can get, because you just have to really look at this and get your answers straight from it. So what you want to then do, this is just one unit circle. So you're going to look at your unit circle for your solutions. Excuse me. So where does cosine of x equal 1/2? Very good, pi over 3. And where else? There should be one other place where it equals 1/2. Very good. And so that's, we can stop there because it says, right here, basically says stop at 2 pi. That's just one time around my circle. So those are my answers. So if there are 2 answers one time around the circle, if I had to go to 4 pi and had to go around the circle twice, how many answers do you think I would have? 4 answers. If I went all the way up to 6 pi, how many answers do you think I would have? 6 answers. So that's one way where looking at the domain can also help you to predict like how many answers you would have. If I'm only going one time around, it's probably just going to be 2 answers. I know this stuff can get confusing, and I'm not sure you guys have done it before, so I highly recommend paying attention. Okay, so here's another example. We'll solve for x on the domain from 0 to 4 pi, and my equation's a little bit different. It's root 2 times sine of x equals 1. So there's actually going to be 2 different things that we're going to have to look at that are a little bit more work than the last example. So because it's 4 pi, we have to go around the unit circle twice. And I'll kind of explain how we do that in a moment. Now, before we can look at our unit circle, though, we have to have this so that sine of x is by itself. You have to get sine of x by itself, or whatever trig function it might be if it's tangent of x. Whew, very terrifying. Thank you. Okay, that'll be on the video. Enjoy that later. Okay, so how do I get sine of x by itself? Okay, how do I get the sine of x by itself? How do I get rid of that root 2 in front? Absolutely, because it's being multiplied, I divide by root 2. So I end up with sine of x equals 1 divided by root 2. That's not on your unit circle though. We talked about this back in like chapter 8. I mean you don't have to rationalize it, but if you want to match your unit circle, you do. So what does it also equal? Very good. So once your sine is by itself, or cosine or tangent, then you look at your unit circle. So we can get our first two answers directly from our unit circle. So where does sine equal root 2 over 2? Pi over 4 is the first one. What's the next one? Good. And kind of like how we already talked about, there are two solutions on this. So since I have to go all the way to 4 pi, I'm probably going to have two more solutions. Now, what did we say the period was for sine? So what I have to do to keep going around the circle like a full rotation, I have to add 2 pi. I have to add 2 pi to each of these answers because pi over 4, I have to go another full rotation to get the rest of it. And 3 pi over 4, I've got to go another full rotation to get the next answer. So I have to add that. So like these two answers are like from 0 to 2 pi. You don't really need to write this down, but when you answer it, but just so you know, then my next two answers are going to be from 2 pi to 4 pi. So I'm going to just do some work down below here. So I have to take pi over 4 and add 2 pi to it. I don't think many calculators will allow you to add that like that. It's going to give you some wacky decimal answers, which we're not looking for. Forgot to mention this, but we've talked about it in previous chapters. Because I've got radians here, I do want to make sure I'm giving radian answers, not degree answers, just as a reminder. So I know this is 2 pi over 1. What do I have to multiply that second fraction by so that I've got 4 in the denominator? 4. So I end up with pi over 4 plus 8 pi over 4, because 2 times 4 is 8, and 1 times 4 is 4. There's an invisible 1 there, so if I have 1 pi plus 8 pi, 1 plus 8, so it's 9 pi over 4. Now, if you are having a really hard time with your fractions, I might be able to help you on your calculator. I'm not 100% sure about that, but if you're like super struggling, see me one-on-one so I can see if I can get your calculator figure it out. I will give a general tip for everyone at the very end of the notes to help with these fractions and stuff. But I also still have to get my last answer, so I have to take 3 pi over 4 and add 2 pi. Well, I already figured out 2 pi is the same as 8 pi over 4. So I've got 3 pi over 4 plus 8 pi over 4, which is 11 pi over 4. So that is my next answer. So only what I put in the box is like what your answer is, but I don't really mentally do my fractions that well, so I like to do a little work for that as well. So up next, we are going to change the domain in a different way and talk about that. And then also have a tangent function, which is a little bit more complicated as well. So we are still kind of like kicking it up a notch every question. Are there concerns before I go on to tangent? Have you guys done this before? I feel like I have a lot of people like not really fully paying attention, so it makes me wonder if you guys already know what you're doing. All right, so like I said, we've got tangent. In this case, tangent of x equals -1. But my domain now, instead of going, oh, this is a slight typo, also there should be an x in the middle. But instead of going from 0 to 2 pi, it actually goes from negative 2 pi to 2 pi. So that's like a little bit weird. You freaking out? So we actually have to go, because of this negative 2, we have to go backwards around the unit circle. So think about it. In the last example, we went to 4 pi, so we had to add something to go forward around the unit circle. If I have to go backwards, what do you think I'll have to do? Subtract. We will subtract. I'll talk about what we subtract a little bit later, but we will have to subtract something. Now, the other complicated part is that tangent's not directly on my unit circle. So I'm really looking for when sine divided by cosine equals negative 1. So how would I get a negative 1? How would I find negative 1? Looking at my unit circle, doing sine divided by cosine. Very good. 1 would have to be negative, 1 would have to be positive. So that's looking at quadrants 2 and 4. And it would have to be the same number. So I'm looking for root 2 over 2 divided by root 2 over 2, making one of them negative, or the first one could be negative. So that's what we're looking for. So sine and cosine both being root 2 over 2, but being opposite signs, positive and negative. So where do you guys find that on the unit circle? All right, the first one's at 3 pi over 4. Very good. All right. Now let me tell you, it's not required for you guys to write your answers from least to greatest, but I do know in the back of the book it's written that way, so I'm doing that right now just to kind of match up with that, but I'm not going to care if your answers are in an opposite order, okay? Now, the reason why I put them second is because these are my answers from 0 to 2 pi, so I have to find my answers from negative 2 pi to 0. So that's why those ones are going to be smaller numbers. Now, here's the other difference. If this was sine or cosine, I'd have to subtract 2 pi. But what's the period for tangent? So I only subtract pi in this one because it's tangent. Now, if it was a cosine problem or a sine problem, you would subtract 2 pi. And going back to the previous example, we added 2 pi. If the previous example was a tangent problem, then we would have to only add 1 pi. So keep in mind that difference between the cosine and sine versus tangent. The other difference with tangent and its domain being smaller, if I do 7 pi over 4 and subtract pi, I'm going to get 3 pi over 4. So actually, I know on the sine and cosine ones, you like do each of them. Well, for tangent, you have to just take the first one, subtract, take your answer, and subtract. So that's a little bit different as well. So I have to take 3 pi over 4 and subtract pi. So what do I multiply pi by? So it has 4 in the denominator. 4. So I've got 3 pi over 4 minus 4 pi over 4. Yeah, well, wait, what'd you say? Negative, yeah. 3 minus 4 is negative 1. So you've got negative pi over 4. Well, I know the fractions can get tough, so if you do have a question, please raise your hand. Let me clear it up as soon as possible. Try not to sleep through this. I want you guys to be successful in this chapter. We're finishing out third quarter with this chapter.
Well, I don't know if we're calling up for this, but could you just figure out that because other side negative, then the positive one.
Oh, I have no idea. I mean, I'd have to think longer about that. All right. So then I have to take negative 1 pi over 4 and subtract it, but I'm going to wise up. I know that pi is equal to 4 pi over 4, so I'm just going to change that right away. So then I've got 1 minus 4 is negative 5 pi over 4. I'd have to think about it longer, like in terms of a different example, just before I can give you a real answer. I get what you're saying though, but I just need a little more time. Okay. We aren't going to do any full-on examples, but I do have to tell you about one other way where the domain gets kind of funky. Does that have to do with number 4? So, any questions before I just do one other thing? We just kind of talk about one other thing that could happen. So the last thing that could happen is that sometimes inside here, it's not just x. It might be 2x, 4x, 3x, or it could be x plus pi over 2, or x minus pi over 2, or something else. So if you've got something else inside here, you have to do whatever's happening here to your domain as well. And I'm going to show you what that looks like on the next screen. So we're not really going to solve these right now, but just kind of prepare you for when you see that. So if this is my original domain, and I've got a 3x, then I have to do whatever's happening to everything here. So, for example, how do I get from x to 3x? What do I times by to get from x to 3x? 3. So since I have to times by 3, I have to times everything by 3. Well, 0 times 3 is just 0. But what's 2 pi times 3? 6 pi. So if I had a problem that was like, okay, let's say it's tangent of 3x, I'd actually have to change my domain and find all of my answers there. So that gets a little bit funky as well. And then okay, I'm just remembering something. I forgot to tell this to my second hour. So the other thing is, since we're timesing by 3, we're going to get all of our answers for 3x. So I would have like 3x equals whatever, whatever, whatever. How many answers do you think we would have if we're going all the way to 6 pi? Well, there's 2 for 2 pi, 2 more for 4 pi, 2 more for 6 pi. 6 answers, so we're not doing a real problem, so I'm just kind of making that up. So then 3x equals those answers. You actually have to divide that 3 back out. Now, if you try these on your assignment and need some help, just make sure you ask them tomorrow. Same kind of thing here. So here we're adding pi over 2, so I have to add pi over 2 to all of these. So 0 plus pi over 2 is pi over 2. And that would be x plus pi over 2. And then I have 2 pi plus pi over 2. Well, I can kind of figure that out the way I was doing the fractions before. I'd have to times this by 2. So I have 4 pi over 2 plus pi over 2. So that would be 5 pi over 2. So that would just be something that's a little bit different that you have to kind of worry about there. All right. So the step box is kind of a big question in a way, because the step box says, what is something I need to remember from this section? It's like a dozen things, right? That's what I mean, it's big. So what's like one thing you feel like you have to remember from this section? For sine and cosine, you've got to add 2 pi. For add or subtract 2 pi. For tangent, it's just 1 pi. Take a look at your domain. The worst thing that happens is, like, if you forget to look at your domain, you might have like an extra answer you don't need, or you might have not enough answers, so you might have to just do a little bit more based on that. Don't forget your unit circle. You definitely need that. Keep in mind the assignment is 11A.3, so don't just open up 11 and start working right away. Make sure you're in the right section. And here's a little helper hint for your adding these fractions. 2 pi, what if I wanted 2 on the bottom? What would I have to multiply by? 2. So that'd be 4 pi over 2. If I wanted 3 on the bottom, what would I have to multiply by? 3. So I'd have 6 pi over 2. I'm sorry, 6 pi over 3. If I wanted 4, I'd have to multiply by 4. That's 8 pi over 4. Let's say I had 6. I'd have to multiply by 6. So that'd be 12 pi over 6. So if you're having trouble like converting your fractions into common denominators, this might help. Same thing with pi. Pi is the same as 2 pi over 2, or 3 pi over 3, or 4 pi over 4. So I thought maybe writing those down would help you with some of those conversions. Now, obviously you can use your notes on quizzes. You won't be able to use that on a test, but